तक क्लियर है?
Okay, so good evening, dear students. So today we are going to discuss about the final rating and connection of the inverter. So this will be presented by Gautam and Shaptarshi. So now Gautam can start.
Good evening, everyone. In continuation of our project Inverter and Motor Control, after generating inverting pulses with and without introducing that time, we came at a stage where we will be calculating the parameters of our equipments which we are going to use in our experiment. The slide on screen is an analog oscilloscope or CRO, which is used to measure the voltage, current, frequency, etc. with the help of graph obtained on it. And the another one is function generator, which generates functions like sinusoidal, triangular wave, which we required in our experiment. Next is digital oscilloscope. This is modified version of CRO, which is composed of various software, hardware modules that work together to capture, process, display, and store data that represent the signal of interest of an operator. The next one is DC source, which we are going to use as a source, constant voltage source and constant current source. Now the next slide is our motor driver, which name is BTS 7960, which is connected by our Arduino to convert DC voltage to AC. It will be shown in following slides. The driver which we shown in earlier, that's specification are its input voltage vary from 6 to 27. That means we can give its voltage 6 to 27. So we can choose accordingly in between this range. Maximum current that it can hold is 43 ampere, and its input level, which is going to Arduino, that is 3.3 voltage to 5 voltage. Its duty cycle is 0 to 100%. Accordingly, we will select from our parameters. Its operating frequency is 25 kilohertz. So we will calculate the frequency which comes under 25 kilohertz. Now this on screen, it is 8 mega 328 pin out diagram, which when we will be connecting with the motor driver, we will be shown in the next slide. The slide which are shown in previous, that's specification features are, and now the point number, this one PWM channels 6 are there, which we are going to use, and all the other specification are general, that is VCC and ground and etc. Now the next slide is I hand over to Saptarshi, who will explain the another one. Saptarshi.
Thank you, Gautam. In the next slide, we can see that the oscillator frequency calculation is done for the inverter. We can see that the oscillator frequency can be calculated as clock frequency divided by twice into prescaler factor into top of count. Here we have taken the clock frequency as 16 megahertz, prescaler factor as 1, which is the default value, and top of count as 1024. Since we are denoting the clock using 10 bits, therefore top of count will be 2 to the power 10 or 1024. Therefore, putting these values in the formula, we have obtained the oscillator frequency to be 7.8125 kilohertz. In the next slide, we can see the connections which are made in our project. We can see that the Arduino Uno board is connected to the BTS 7960 motor driver. The PWM pins of the motor driver are connected to the subsequent PWM pins of the Arduino Uno board 3 and 6, which is shown as follows, and VCC and ground of BTS of the motor driver is connected subsequently to the 5 volt and ground of the Arduino Uno, and ENR and ENL are subsequently connected as high, which is are always high and connected to the specific digital pins 2 and 4 as shown here. Now in this motor driver, we can see that the input DC supply, which is 12 volt given here, is connected to B plus and B minus, and we get the output AC supply which is given through M plus and M minus pins, which is transferred to the which is connected to the transformer, and the other end of the transformer is connected to the load. This is the overall connection that we have used in this project. In the next slide, as discussed above, the voltage should be within the range 6 to 27 volt, and the maximum current should be within 43 ampere, and the operating frequency should be within 25 kilohertz. Therefore, we will select the voltage and current accordingly. In the Arduino board, we have on which we have prepared the PWM. As we have calculated for the oscillator frequency, we will select the 7.8125 kilohertz, which is less than the maximum operating frequency 25 kilohertz. Now, as the voltage and current of the inverter becomes fixed, then the multiplication of them gives us the power. Therefore, the inverter transformer that is to be used should have a power rating greater than at least the input power supplied to the inverter, or else the transformer may get damaged. Therefore, we have selected the transformer power rating to be 100 watt, which is greater than the input power. In the next slide, we can see that the final parameter values which we have supplied. In the DC input, we have given 12 volt 2 ampere. Therefore, the input power will be 24 watt. Considering that we have considered the transformer rating to be 12 volt AC to 230 volt AC, and 100 watt should be its power rating. Now we have calculated and selected the PWM frequency to be 7.8125 kilohertz, and since there is some power losses incurred for the DC input, total 24 watt is not transferred to the load. Therefore, we have selected the load rating to be 18 watt. This is this concludes the process of our project. Thank you, everyone.
So as per this presentation, so people of Indian Institute of Engineering, Science and Technology, so they have selected this one. These are their final parameters. So they will be giving 12 volt DC from their regulated power supply, and it can draw 2 ampere. And this 12 volt, it will be converted to 12 volt AC. So definitely to operate our normal domestic home appliances, because that is 50 hertz and 230 volt. So definitely you need a transformer of 12 volt AC to 230 volt AC. But here the input DC power is 24 watt. So your transformer rating should be at least 24. So here they have selected it is 100 watt, because that much less rating may not be available. And as you've seen that Saptarshi told that the maximum switching frequency of the motor driver board, that is 25 kilohertz. So they chosen the frequency of 7.8125 kilohertz. It is well within the limit. And as there is a conversion, this transformer and all these things, there is efficiency may not be 100%. So it will be lesser than 100%. So due to that reason, they have selected the load rating 18 watt. So with that, they will be finally implementing the project. Thank you so much.